Hi, so I'm Ryan Casey. Today I'm going to talk to you guys about data modeling for the modern data warehouse. I'll speak a little bit, maybe briefly, on third normal form and kind of highlight what the difference is of a star schema. So I have a website at aimyourdata.com, a blog at Rhino Data, and you can find me at Twitter at RyanKCMBA. I have a LinkedIn group that you could also join if you like, and a YouTube channel you can find me at. This is just a little bit more about me. I've been doing this for about 20 plus years now. A friend of Redgate and a Microsoft MVP. Yes. Okay, sorry. Oh, perfect. Oh, that'll work a lot better. Okay, so basically what I want to start off with, well, that's going to be really loud, is the value of enterprise data. So Gartner has something that I picked up here, and it talks about basically that most organizations currently aren't even recognizing their own value in the data. And something, I won't read it to you here, is they talk about velocity, variety, and volume, which, if you're all familiar, that's big data. So why should we data model? Enterprise data collaboration and consensus is a primary reason. So if you're in a dev environment and you have a bunch of developers, it makes a lot of sense so that you guys can take the time and organize so that you can understand where you're going and what you want to develop. Collaboration and consensus is also useful for the business and other people in the organization, such as maybe SharePoint developers where you'll be pulling data from, programmers, and including the C-level if that project happens to organize to them. You can catalog and maintain valuable model metadata. Encourage model first as part of the agile sprint. So what I mean to that is essentially when you have an agile sprint and say like you're going to have new columns come into your data warehouse, if you model first, you can take advantage of some of these modeling tool features that I'm going to talk about. So the benefit of this kind of modeling first approach is that you're keeping your models up to date as you're going through your sprints. However, the problem with that is no matter how hard you try, we end up with deadlines and we miss and we get out of sync. There are some tools in here that'll help you because, for instance, if you have a common scenario where you're getting a hold of a data warehouse that essentially hasn't been maintained, a model in, I don't know, a year, 2 years, 3 years, you might use reverse engineering. But that could take you possibly 3 or 4 weeks extra work if the system itself doesn't have like primary keys, foreign keys, depending on the level of what went into the model that you just extracted from reverse engineering. You might have a lot of additional work to get it up to where you really want it for your model that you're going to use every day. So what happens is if you do a reverse engineering and then you get out of sync, well, it's a real issue because you don't want to spend every time you reverse engineer another 3 days reverse engineering and doing all that work you did to get it up to where you wanted it. So they have some tools we're going to talk about that can help you with that, like with code, where you can merge and do, determine which one's the most accurate version. So you can handle versioning as well as that. Things like that are forward and reverse engineering is what we're talking about, and requirements gathering and validation. So today we have what I like to call a multifarious data landscape, and that's having or occurring in a great variety, complex internal and external data sources. They can be structured and unstructured data, big data and on-premises, silos of disparate data, mismatched shared resources, ERP, HR, and directory services, cloud, SaaS, software as a service, and Internet of Things. It can also include decaying legacy systems where you have no decommissioning strategies, data warehouses, data marts, ETL, Hadoop, and data sciences. So when you have all these different varieties of information in your organization, that becomes really complex. And we have to have systems, and modeling can definitely help us in dealing with all of these different multifarious landscapes. So these are some of the things where data modeling actually can help us. We can use conceptual, logical, and physical data models, which we're going to talk about here in a little bit. Modeling and understanding the entities, the relationships, the attributes and the identifiers, and the cardinality, which is real important. We're going to talk about that. And then things like I was talking about where you can compare your data models to keep them in sync. So you can also compare your logical to physical models to see if they've gotten out of sync. But you can also compare, like I was talking about earlier, your model compared to what you have in production, right? If you're going through a standard dev to UAT to production lifecycle, but your development model or the model you're working off becomes out of sync, you want to be able to use these compares in order to help you quickly resolve those issues instead of having to reverse engineer and spend the time over getting it up in sync. We have data lineage and naming standards. And a real concept that we're going to talk about today in star schemas is that your data is in context. And I know that doesn't seem like a big valuable thing, but the whole idea about a star schema is understanding the context of what you're going to be analyzing. And so when you put the facts in the middle and all your dimensions, those are your context. A traditional third normal form database had no context. And if you guys have ever worked with older systems like Fiserv or an AS400 system, an IBM Service system, Cobalt middleware, it's really interesting that you'll see a lot of the columns, because they were 32-bit, they only were like 8 characters wide, and they might be like DB021. And unless you know what DB021, there's no context, right? None. Data warehouses and star schemas, specifically what we're going to talk about, they organize the data with context in mind, and those are the dimensions. So how do data models deliver benefit? So essentially we have this cylinder here where data models at the bottom can support your data and your organizational systems. In terms of data, they can minimize redundancy and also help to make sure your data is shared in compatible ways. And that in turn actually supports your business, where we can reduce costs, we can improve efficiencies, reduce risk. And all these things, when you start modeling your data and understanding your data, can be implemented in knowing like when I worked for GameStop, they had so many production databases, probably about 200 production databases. And they spent most of their time moving data around, literally. They had got so big with so many systems and even production systems. They spent a lot of time just moving stuff everywhere. With model, and they were lost, though, at some point, because they didn't have models for it. That you just had to figure it out. So modeling, when you start getting really big, is really more necessary. The bigger you get, the more necessary it really is. And these benefits really get really large to the business, because dirty data is useless to the business. So now we're going to actually get kind of the value, step beyond the value of it, why it's important, the data landscape that we deal, and we're going to start talking more about modeling as a concept. So we have 2 types of modeling approaches. Top down, that's where we're starting from scratch, and we're going to start with a conceptual model, and we're going to talk about that. And then that's going to actually drive our logical model, which is going to drive our physical model. And those physical models also can include things like an enterprise model and a data lineage. But the idea is we're starting from the top, kind of a concept, and kind of working down. The other model is the bottom up, where we were talking about using the reverse engineering features. And that's where we're going to reverse engineer. We're going to try to identify the logical and physical layers from that. And we deal with the existing data lineage. And those are basically the 2 different methods you can use when you're modeling and using the modeling tools. So we have forward engineering, and the professional tools, say like Irwin or Idera ER Studio, they can do forward engineering, full DDL, partial DDL, and alter and extended creates. And on the reverse, they can do full DDL and partial DDL. So that means they can generate all your scripts for you. So that's really feature important. So the way you can use that is if you model your star schema in advance, and you can then create all your scripts to create all your tables that you wouldn't be able to just go in and right-click on SSMS and generate scripts because they don't exist. Well, if you have a lot of scripts, that can save you a lot of time, right? So that's simple, but what's an altered extended alter? I'm just kind of curious. Does anyone know what an altered extended alter or what they're talking about that? Okay, have you guys ever been in an organization where the lead on your team or your manager likes to keep their table structured in a logical way, meaning they want all the foreign keys and primary keys at the top. They might have your dates next, and then if it's a fact, measures next, or if it's a dimension, your attributes. And at the very bottom, you always want to keep your ETL maintenance type columns. If it's a type 2 dimension, is current, start and end times, things like that. But you want to keep that hierarchy so that your organization and all your tables meet some sort of standard. Well, if you were to change and add a column, new attribute to a dimension, if you just use alter table, it's going to put it at the bottom of the table outside of your hierarchy. So an extended alter is where, well, if we were doing this process manually, right, we'd do an insert into a temp table, store the data, drop the table, rebuild it recreate it with the right order that we want, and then insert into back, and we just move on. But it'll do all that for you, is what an extended alter is. So it'll even do extended alters and things that'll help you manage your code as well. So what does acceptable data look like? If we're going to talk about data modeling, and we're actually going to step into talking about the context of the data and why context is important, and understanding it from a business example, well, we got to understand is what does good data look like, right? Because data in is junk out. So it has to be discoverable and accessible. It has to have good comprehension and context, right? We have to understand what the measures mean. We have to have business rules that define them. And in many cases, if we have master data management, hopefully we have organizational agreement on what all the definitions mean. And that's quite a big deal in some organizations to get them all to agree on the same measure and what that measure actually means. So we have compliance definition for appropriate presentation of the data, so that we're ensuring that there's always one value or one vision of the truth. So one system's not showing one value and another system's showing another value, right? All your ratios match from system to system. The data and the systems that we build are accurate, modeled to complete and relevant. The data is consistent and has conformity. And we don't have duplicates, or we're also doing things like referential integrity. Does anyone here know what referential integrity is in a star schema or a data warehouse? How do we manage that? Okay, how about referential integrity for just a traditional database? What's that? Anyone? So referential integrity is how we ensure the relationships between our foreign keys and our primary keys, right? Because if we have a third normal form, we're actually taking data out of a de-normalized table and normalizing it. So that's ensuring the integrity of that relationship when we've now normalized or taken some data out and related it to another table. So in a data warehouse, we ensure referential integrity by using surrogate keys. So anyways, that's real important. It's just referential integrity is still important. We just have a fact table in the middle with all our dimensions, but the surrogate keys that give us our relationships, our foreign keys back to the dimensions, are referential integrity. So we can talk about conceptual models. From a technology standpoint, they're technology independent. So it doesn't matter whether your database infrastructure is going to be DB2, AS400s, Oracle, SQL Server. It's just at a technical level. It's usually enterprise and entities only. We don't do attributes. And usually the data warehouse team is responsible for that. It's usually not an enterprise architect's responsibility. We have logical models. So logical models give us a little more detail, but they're still technology independent. We're going to consider things like the entities and relationships, the attributes and identifiers. The identifiers are the keys, right? And you also want to understand, in a lot of source systems, the keys are not going to be maybe as nice as in a data warehouse where you have a surrogate key, right? We could have a key that maybe 3 or 4 different columns that makes your key, right? There may not be one clear identifying column, unfortunately. But we have to understand those things and be able to model for that. Terms and definitions and business rules are also at the logical model. Now, remember, each conceptual model is, from the top-down approach, is helping you get more granular. At this level, we're not considering the database and whether it's SQL Server or Oracle. That's where the physical model comes in. And now this is the first layer where we actually are worried about the source system underneath. But this is important because if you have large organizations, some organizations may have a case where you build a conceptual model and you build your logical model, and you might actually have an instance where they have that same model on multiple platforms, right? So this tool or these tools that we're talking about will actually build the physical model for you off that logical model to the different platforms, maybe one being Oracle, one being SQL Server, and it can do all the so a varchar in SQL Server may not be a varchar in another data system. So it can actually help you do the physical layer without having to write 5 physical layers. And if you want to get real technical, the star schema is actually at the physical level. And so Irwin ER Studio will actually create, when you build I'm sorry, not Irwin, Embarcadero ER Studio will actually create a physical model when you build a star schema off it. It's a physical layer in theirs. So anyways, physical models are implementation level, and again, they're usually owned by the architects and the admins. So I'm going to talk a little bit about dimensional models, and we're going to get a little more away from what I would call more the general about modeling and some of the more technical things about what you want to know and be able to read on your models. So enterprise models are essentially large looks of the enterprise from a business process level, and they're usually handed and operated by the architects. So professional modeling. So something I wanted to point out is the entities in the logical model relate directly to the tables in a physical model. And the same as in a logical model, when we talk about attributes, those become the columns. And that relationship is always true. It's just, remember, we're not talking about technology. So they use different words. It's just the way they do it. I don't think anyone's going to get upset if you call them columns or tables, but when you're using the tools, they will identify them differently. So at a high level, these are the different conceptual, logical, and physical models, and they kind of relate to what you'd find on each level. A relationship is an entities where your nouns tend to be places like orders or customers or nouns, and the relationships are the verbs, right? So it will, your noun, your entity, your object will usually do something in the relationship and interact with another entity, another noun, okay? Relationship types can be one-to-one, many-to-one, many-to-many, and we're going to talk about how we notate that. So in college, I was always trained on crow's foot notation, but there's other ones like Chen and some others, but this is the one that I've always used and seen used. And the cardinality just tells us, so like the 0 is 0 and the bar is 1. So if you saw a bar and a 0, it's telling you it must have 1, but it could have none, right? If you saw 2 bars, it would mean the cardinality, it must have 1 and it has to have 1 and only 1, right? If you have the many feet and a 1, you could have many, but you must have 1. If you have many feet and a 0, you can have many, but you could have none too, right? So starting to understand the different feet or the crow's feet will tell you the cardinality of that data, which is really, and it'll also tell you the one-to-many side and the direction if you're thinking about that. Some things that they were talking about earlier, they're Power BI groups and Power Pivot and DAX. Everything's a one-to-many in Power Pivot and DAX. So understanding that's real important because you'll have to build your models to have bridge tables or other alternatives ahead of time so that your cardinality will compatible with the tool that you're planning on using. So cardinality becomes a real important piece because Power Pivot and Power BI are modeling tools. And if you don't have a good model going in, you're not going to have a good model in Power Pivot and Power BI. So quickly, I'm going to talk about what we all are probably familiar with and what we learned in college, and that's third normal form. And how is that different from dimensional modeling, what we're talking about today? So in a third normal form, we're really looking at the execution of a business process. But in an analytic system, when we're modeling dimensional models, we're actually looking for a measurement of a business process. So we're analyzing versus on an operational system, we're looking for the execution, right? The event that's happened, the sale, the measure, right? On a operational system, we're actually, our interaction styles are one of four things: insert, updates, and query and delete. With a dimensional modeling analytic system, we're actually really primarily concerned with the query only. We need to tune for queries, and we also have an ETL system usually behind them. But the main interaction from the user or the customer's query. So for a traditional third normal form, we're concerned usually about individual transactions. That's why we have OLTP, transaction processing. We're writing the sale, we're writing the sell, we're updating the sell, but we're handling transactions. Analytic systems are more looking at current and history, but they also want to know what's changing in the aggregated transactions, not necessarily the transaction itself. Query patterns can be predictable in a third normal form and unpredictable in an analytic system. So just as a reminder, in third normal form, does anyone remember why we do the first three normal forms? I kind of just talked about it there, so it's our inserts, our updates, and deletes, and in order to, our foreign keys and primary keys give us the referential integrity, so that we do inserts, updates, and deletes, those relationships aren't broken, and we don't end up with data relationships that don't make any sense and would give us bad numbers and results. And the third normal form is a process and step to breaking those relationships out and reduce the number of writes. In the olden days, when data to write it was more expensive, right, they really wanted to consider storage. Storage prices are a lot less than they were when relational databases came about in the 60s. So being able to de-normalize the tables, you had less storage and you had less to write. You only had to write the deltas, the things that mattered or changed. Everything that didn't change about the customer didn't even have to be touched when you wrote that transaction. So that's why we did it, but the things we just talked about make it very poor for an analytic system. So why do we dimensional model? Well, essentially because the third normal form doesn't have any history. We might have timestamps, but timestamps are not the same as history or knowing the pattern of a slowly changing dimension. So there's no history. It's not narrative. There's no context. A star schema will help you organize your data in a narrative and contextual manner that makes sense to the business when they're trying to do analytical things. So analytics are different in a production or a daily operational report because we're not just trying to fulfill a shipping doc, right, manifest. We're actually trying to answer a question like who, what, where, when, how, and why, and what can we do to handle some issue, problem, or exception, right? But we have an analytical question. We have an answer of who or what or where, and that's important, and it's different. So that's why we care about the context. If you don't have that context, it's a lot harder to answer those questions. If you start dealing with the data from the context and drill into it, that makes sense. We can solve problems that way. So that's why a star schema's context is so important. Low data quality is we can help with that with dimensional modeling and the complexity of testing. If you have a third normal form data, right? A lot of the queries, especially when you want to do time-based analysis, quarters over quarters, months over months. What if you want to do forecasting out, 2 years? Okay, the relational model starts to get a lot more cumbersome. A contextual model, where we've got a star schema, there are things we do like a date dimension, which can make all that and the actual structure of the context of the data make functions and languages that can help you with that with little trouble, like there is in a traditional relational model that the infrastructure doesn't have any of that built into it. So a star schema is essentially this, and I've been talking about it. It's where we have a fact table in the middle, and we have dimensions that reach out, kind of resembling a star. We're lucky if you have, the key is when you divide your facts into stars and dimensions, your stars and dimensions, you want to understand the grain of your fact table. And that's important in 2 ways. You need to understand the granularity in terms of the most atomic level of the data. Dimensions are usually easy. Customer dimensions, atomic levels, customer. But facts are more complicated. So we tend to look at them in terms of dimensionality. So if your fact touches 4 dimensions and it's maybe region, division, sales, and date, right? That's a dimensionality. If you add another measures from you think might be in the same fact or not, but it requires one more dimension, let's say currency. Those are now 2 different grains or 2 different dimensionalities. Grain can be measured 2 ways in terms of the business process, which is important to understand. What is happening in the business that triggered this event? But that's the way we look at it for a transactional fact. If you're dealing with a periodic snapshot or a other type snapshot, the grain is not that way. It's different. So it's really important to understand grain by dimensionality as well, because there's not always going to be a clear moment that you may think you want. What if you're tracking temperatures? Temperatures are non-aggregative, right? You can't aggregate a temperature. Scientific ratios are non-aggregate. So those things are real important, and that's really what kind of we gain by using a star schema. Oh, I did want to mention one more thing. But as we divide those facts out on grain, and the other piece is timing, right? So you've got your grain and the timing. If something doesn't have the same timing, that needs to be in its own fact table too. But so let's say like now you've got all these different fact tables because they're different grains and different timing. How do we pull reports in that use our dimensions? When you have shared dimensions, what we call conform dimensions, we can use those dimensions to do what we call a cross drill. And it's different than a drill down in, say, your normal like reporting services. What it's actually doing on the back end is it's writing two queries, either MDX or DAX, on both sides of the dimension into the different facts. And it's going to return 2 separate queries at the same grain, right? They have to ensure that both facts, you have to query them at a grain that's consistent with both facts. And then it's going to basically do a union and bring those 2 data sets together. And that's how it can cross multiple facts in a conform dimension star schema. So star schemas tend to have one central fact table and a singular grain, and there are many surrounding dimensions. When you have multiple fact tables sharing those conform dimensions, some people will call that a constellation, right? Because it starts to look beyond one star, you can start to see many stars emerge, right? If you kind of lay out your different models. So we also have something called a snowflake. If you kind of do a third normal form on a dimension, we call that a snowflake. And essentially what you're doing there is you're de-normalizing a little bit. Imagine if you had a sales fact and you have a product dimension. In many cases, in fact, if you look, this is right out of the Microsoft's sample database, right? If you're familiar with it, they actually, in their data warehouse sample, they have a snowflake on product and they give you a subcategory and a category, right? And so snowflaking in some cases can be useful. For instance, that's useful if you need to change those values often and you want them to flow automatically in all your reporting. But it's also not useful if what that data is was high cardinality, because the cost of managing it is very expensive now. But if it's low cardinality, like 4 or 5 different things, and you want that flexibility, you can consider doing a snowflake, even though it's technically not a star schema. And Microsoft has an example of that. So I'm just talking about here, you can also do a de-normalized third normal form, and that's a hybrid of a, and so what I'm saying there is almost, remember, dimension has many attributes. So if almost, say, all of your attributes are in the dimension, but you move one of them out into a snowflake, that's a hybrid. You've got a snowflake, but it's only on one attribute. Everything else is a true star schema. See what I'm saying? So you don't, just because you make a snowflake, not everything in that dimension had to be snowflaked. So that becomes a hybrid. If you have a dimension where everything's in a star schema, but only a few attributes go into the snowflake, that's a hybrid. Okay, so slowly changing dimensions. We need to understand this for modeling if we're tracking history. Can anyone tell me what a slowly changing dimension is? And if you've worked with them in your business. Okay. Type 1, type 2. Right. One of the reasons why I wanted to put this in the conversation of modeling, because if you're going to do and have history to your dimensions, it's important that you actually understand that you have to have those attributes to track the changes in the history. But it's also important to recognize that this is some place where if you're using a modeling tool, when it creates your scripts for you, you're going to save a lot of time. Because if you didn't, you're going to be adding these in on every single script you write, managing this. For your type 1s, there's even columns. So technically for a type 1, you only need an insert. You don't need an update. Now I'm going to give you an example why I always suggest having an update. There are times where, remember how we were talking about we wanted to maintain the organization of our table, the columns in it, and the order they came in, and we did an extended alter? If you do that on a type 1 that only has an insert date, your whole data warehouse is going to look like it was inserted yesterday. And that's not a big deal if people don't know, but you're going to have some power users like I did that are going to go in and they're going to say, everything updated last night, everything's from yesterday, it's broke. Just a warning, okay? If you have an updated date, that becomes, when did it enter your data warehouse? Never going to change it after that first time. So you always say, no, this is when it came in, we did some maintenance. The new inserts have happened on all the rows. But when this came in to our data warehouse is that original insert date. Everything else is an update. That's just my personal experience. I had a headache once where that's exactly what happened. Nothing was changed. None of the data was lost, but we updated everything. So many-to-many relationships and bridge attributes. So we were talking about many-to-manys and how Power Pivot and Power BI cannot work with many-to-many relationships. So the key to that is a bridge table. So for instance, if we have a fact and the fact is storing information about a practice in an organization, and that practice has practice leads and practice managers. But for every practice, there can be many managers and there can be many leads. How are you going to model that properly? Right? That's a many-to-many relationship. So for each one of those conditions, we can build a bridge table, which has the unique combinations for every occurrence of where, in the case of the practice lead, that it had a relationship for practice lead, and in the case of practice manager, where it has a relationship for practice manager. Now that seems easy. Essentially, a bridge table is a fact table. It's a bunch of foreign keys. here's the tricky part. This can actually be extremely complex if the dimensions on either side of the bridge are a type 2 slowly changing dimension. Your life just, yeah, you want to, this is going to suck, is what you're thinking. I promise you, it's very hard. And what's even worse is if there are deletes. Because if there are deletes and these relationships are changing, you might be thinking, okay, well, I'll just leave the deletes. Well, that file is going to grow enormously big if it's something that the relationships, the bridge tables change a lot. So essentially, you've got a fact table where you're going to have to manage inserts, updates, and deletes efficiently. I got some good news for you. I've seen some tricks lately, and for you people using DAX, if it's not too much data, I wouldn't suggest doing this. You can actually write code that'll get the unique relationships on each side of the bridge and build a dynamic table with DAX. And no longer would you have to do it in ETL and manage that bridge table for inserts, updates, and deletes like a fact table. So anyways, I've seen it done, and it's interesting, but I would also recommend that you need to consider, you know, what is the size of the data in that bridge table, and performance could be an issue the bigger that gets. So, you know, just don't go run thinking I'm going to do that. Make sure you test it. But those options are available to do bridge tables and those calculations in DAX. Something I wanted to mention in data modeling, lookup tables. So how do we use lookup tables in Power BI and Power Pivot? We use them essentially all the time. They might call them a relationship table. Well, they'll never have a relationship to them, by the way. I started to use the word relationship, so I wanted to correct that before I gave a bad hint. Parameters. So your parameter values, distinct lists, they tend to be a lookup table that we would use in Power BI or Power Pivot. So lookup tables just essentially help us get information that we need maybe for our parameters. They can help with filtering, right? Because a parameter selection can be used against your filtering of your data, things like that. And finally, the last modeling technique I'm going to talk to you about, this is something that people don't think about, but when you're dealing with column store indexes for analytic systems, that's actually a modeling technique. But it's happening it's happening, and it's a transformational between the logical and physical layer. We're just lucky that the systems like Vertipack in your tabular model system is actually, the system itself is doing all this for us. And then if it's an index and you're actually doing it at the data level, right, then it's SQL Server doing indexing for you in a column store format. But it's doing all this column store storage of the data for you on the fly. But we don't fortunately have to model that. That's not part of it, but I just kind of wanted to point out to everyone, this is actually part of modeling and data modeling, the column store concept. It's just moving the data in the model in a different way. So the last part here that I want to talk about is we've talked about modeling data, but I've also talked about probably about 5 or 6 or 7 times is the importance of the context of the data. And context is really important also in understanding the business. So I would like to point out that Microsoft Visio is a really good tool that'll really allow you to understand the business. You can do flow charts, swim lanes, business process. I've got some examples that I want to show you. If you have your MSDN, you can get 2010 and it will still reverse engineer for you. Up until 2010, Visio did reverse engineer, but they took it out. But if you have your MSDN or access to the older version of Visio and your company doesn't pay for an expensive modeling tool, that's one place you can get reverse engineer your model through Microsoft. So one example here that I have is that I use in Visio is when I'm kind of with a customer and I'm trying to share with them what they could implement in the entire stack. This was a model that I used for years for the on-premise piece. When I start talking about Azure and the cloud, we have a bunch of different tools. But we start pretty much where we bring our structured data in from our source systems. We deal with the ODS, master data management. I'm not going to go through this because I'm sure you're all very familiar with it. But this is a way that you can use something like Visio to help visualize the data and the process of the data and the tools you'll be using along with the data model that you just were designing that's more related to the data. Here's an example that I did where I was explaining when it made sense and the order that you had to load your tables if you have foreign key relationships, right? If you have a foreign key relationship, you have to load the table that had the primary key before you load the other table, or else you're going to get load issues. And so I just diagrammed that for the business user and the customer to indicate with the 1 and the 2 and the order that data had to be loaded so they could understand. And the same with, that's a kind of a scale-out model of an environment that we had in SQL Server 2008, R2. So a lot of the things that you're going to see up here, are more not the tool stack today. For instance, SharePoint integrated, things like that. But I was able to kind of illustrate to the business, what does our scale-out model look like, right? We're on one server in dev, and we have a fully integrated SharePoint environment. But in UAT, we had SharePoint integrated, we had Kerberos, but we didn't have Kerberos in dev. And then production was a 4-server environment scaled out differently. But I just kind of want to point out, data modeling is really important, but the modeling of the context is just as important as everything else, and understanding how that's applied to the business. And that's it. Questions? Sure.
So there's a lot of kind of well-established relational data modeling techniques. Just what do you see out there in the last 2 years since Hadoop really started to quite a long way back for a lot of folks? But I've seen some people who are kind of doing like modeling, like model on query. It's kind of like an idea, like schema on query, right? Like
Yeah.
it's unstructured until we write a query.
Yeah.
Do you still see demand and need for continued progress in like using a relational database to do that modeling, or was that something that we had to do because relational databases were the best thing we had at the time?
Well, your unstructured data is like totally different, and they've got actually it's not Spark, but there's a new version of the Apache right now, and I don't do a whole lot with it, but I know that whole space is actually evolving right now in order to do the exact same things you're talking about. So I would say that's in the process. When you're talking about the structured data and bringing it together, SQL Server can work with Polybase, and you can actually write queries that can help you bring the both back. When it comes to modeling and how it's changing by the big space, I think that at some point you're going to want to combine it with your structured data, right? So I don't know that you're really modeling in the same way. Like I had a company that their big data was coming through. They were an architectural firm, and they would have in all the buildings, they would plug into the outlets, and on the badges of people in their buildings, they had RFID chips, and they could literally track you floor to floor, office to office. At any given time, they knew where someone was by their badge, and that actually went to a third-party company, and then they used Stream to bring that big data source over, and then they would store that in some storage over in a Hadoop data lake on the SQL Azure side. And so, but the modeling of that area is quite new, and how to manage that in the best way, I think it's still changing. But at some point, I think these techniques are very valuable still when you're going to ask yourself, how is this unstructured data going to be used? I've got it however it came to me, whether it was Stream or, I had my own big data source and I was collecting it. But at some point, how am I going to bring that with my on-premise and my structure? And that's where we have a gateway, and you have a lot of work that's going on today is how do we build or set up a Power BI environment that's going to handle the on-prem and the gateway, but also consider the things that you're talking about. So I don't think it's going to replace them, but I definitely think that there's going to be its piece that's evolving, and then at some point when you bring the two together, you're going to have to model it. Modeling will still be there. I think definitely, because OLAP with the traditional multidimensional, you could have many-to-many relationships. We could define the type of relationship it was. There was a whole, it looked like a matrix, and you define, it could be many-to-many, it could be a fact, right? You could look up from a fact table and turn it into a dimension, which is something we do. I didn't talk about it, but we do that all the time. If you want to do time-based analysis on some events of facts, we take that range of facts and we'll turn it into a dimension, and that allows us to slice back on that fact and get your time-based analysis. So, yes, the difference is because the tools are different. They have constraints, and it's not multi-dimensional. OLAP for SQL Server has been around for a long time. It's a very mature product line. And the features are not all the same and available yet to allow you to do the same things. So modeling is different, but I would also say that because of the power of DAX and because things can be brought into memory, a paradigm that I've also seen is keeping the model simple. And the model forces you to do that, the one-to-many requirement, the fact that a traditional role-playing dimension, which in multi-dimensional aggregations and doing your aggregates, it could figure all that out and pre-process and it worked fine. But the way DAX handles it, there's only one active relationship in any given time. So you're really, actually, to do it right, you're spending a lot more time defining your DAX functions, which have the power to do iterations and to do groupings and to summarize, but you're rethinking it. But the key to that is you've got a simple model, which you can exploit doing it right in your DAX, the power of DAX, which is all in Vertipack and in memory. So that paradigm's changed a lot, because in traditional ETL, we're spending a lot of time, everything, handling it before you model. But if you can handle it in DAX where it's really fast, you're going to reduce your processing time, right? And all that, and that's real important. If you have a model that's taken 3 hours to process, but if DAX is powerful enough to do that calculation live, why put it in your processing at all? That's becoming your bottleneck, and the models are changing because of the performance. So, yes, definitely. Anything else? Any questions?